April and May, most video I have because I have a class with you. That's good. So I would like to present our CEG 452 engineering survey. Okay. So can you see my screen?
Yes, doctor.
Okay. Can you see this chapter 5, area and volume?
Yes,
Yes,
doctor.
doctor.
Yes. That's good. That's yes. You still remember that what you done. So what you done is actually one of that is doing a leveling. So leveling, because we want to know a Earth profile, or sometimes the people say land profile. Actually, it's Earth profile. So the Earth profile give you, we call it, this land is not straight. We call it ground is we call it, you have rise and fall, right? And for the highway, for the building, normally the people love a straight, flat. People wants something like is very in straight lines. So, for example, that area we call it is very low because we want to build up the highway. So that area we put a bridge to make sure the alignment of road is flat. So people love flats, people love straight lines, people love the formation is a very, we call it is a very it's very easy going for, we call it shape. For example, is a trapezium shape, triangle shapes, polygon shape, and so on. And we can calculate area and volume. Number one, if you can see this drawing, okay, this drawing. So this one is, we call it the area for traversing, right? And this one is, maybe you want to know the volume. Volume of what? Cut or fill? Is fill. So how many meter cube the soil you need to have to fill up this area? And actually this is a road construction. So here we call it embankment. So this one is a process of fill up. It's not cutting, fill up. So especially this embankment, we use it or we apply it on, we call it the low land area. For example, that you are from Gurun going to Alostar, you are following a highway. So the highway is a project Lebuh Raya Utara Selatan. So from Alostar to Gurun, or from Gurun to Alostar, you can see that your left and right is a paddy field. So for the road construction is not, we call it give you the right one when you put the roads the level same with the paddy field, because the water will be raised up. Even though we are doing, we call it embankment, but the low embankment, sometimes the area flooded. So you have flash flood sometimes. So you must put up a lot of fill up. So you go to fill. This area is a very huge embankment to make sure our area is safe from the water level. Okay, and sometimes the water level also can go to your sub base. So what we do, we put it here, waterproofing layer, either using geotextile layer or another method that recommended by engineer, right? And the water come from the two in Malaysia. One is rainfall, and another one is we call it from groundwater. Okay, and sometimes the rainfall is going down and it penetrate to a certain level, and then it's going back to here. So for example, you have rain here, and this one is penetration. Some is going to straight direct. Some's going back to the basement of the embankment. So we must protect, and we must uh, have give a good protection to embankment, because we don't want the road settle when we have water, and the water soaking with our base of our embankment, or sub, or we call it road base or sub road base, mean that your structure of your field is is going to break down. So that's why we always control the water. Alright. Okay. And actually, area and volume, we just want to calculate about. Sorry. We just want to, we call it to calculate about area and volume, because this is, we call it survey engineering. Right. We have 5 slide. We try to finish tonight. If we have, we call it a time. Okay. Number one, learning outcome. So after you finish this, we call it presentation, what you should be able to, number one, compute is mean that you know how how you make it how you use some formula, and you calculate the area from plan and field data. A regular or irregular boundary mean that maybe the boundary is irregular, mean that rise and fall is very heterogeneous, and then regular means it's a quite flat boundary. We can calculate. Number two, compute volume for cut and fill. We learn about spot height. You can remember that contour, grid leveling, mass hall diagram, and so on. So we got it, longitudinal of profile leveling. This one is a very essential, because you are a civil engineer, you must understand how to read, we call it longitudinal of profile leveling. Okay. Number one, what is longitudinal or profile leveling? To determine elevation of point spaced apart at no distance along a given line in order to obtain the accurate outline of the surface of the ground surface. So I will show you later after this. So this is, we call it longitudinal profile leveling, where you have, we call it, this one is our profile. This one is our profile. This one our profile. And you can see that we have two dotted line, and one straight line on top. One straight line on top. This one straight line, This one straight line, Straight line. Straight line. So you look at this, we call it example, that's we call it the drawing. Okay, so you have this one is a finished road level. So I mean that you want, we call it to build up the road at this area. This boundary. So what is, we call it, finished road level? You can read from this one. 1, 2, 3, 4, 5, 6, 7, 8. To form this one, the straight line one. Straight line one, Okay. Existing ground level, so mean that you have this profile, dotted line. This one is the existing one. Okay. Alright. The existing one. So you can see that the existing value is 72.04 until you have 91.95. Okay. Alright. So you have this one, Let me, we call it zoom a little bit. Okay. So I just a chance, we call it my slide. Okay, so actually, how we want to interpret this? Okay, I will show to you. So how you interpret this one? Okay, number one, you go to zoom this area, you can see that ground level 89 89.90. You can see this one 89.90. 89.90 is, we call it the existing ground. 89.9 89.80 meter, the height. For the road proposed, we cut it 89.80. We make sure that we are at this level 88.67. So when you look at this one, you understand that 89 is this point. 89 is this point. Then 88.67 this point. Okay, mean that we should cut this. We cut this one. We cut. Alright? Until this point, we cut. Because this one is chain. Okay? So this one, we want to make sure like this. So this area, first we cut. Now we fill up. We fill up. Until to this point. Okay? Okay, wait a minute. I should erase first. Okay, now, what we have now? So this area we have around 71.41, 71.41 like this. Something like this, But this area 72.11 here. 72.11. Mean that at this area, this one is your proposed of new roads. And this road actually is, you still remember that it's climbing the hill. It's something like you are climbing the hill. You are climbing the hill. Okay. So with alter, we call it the existing one. The existing one is straight line. It's a straight line like this. So that's why you can see this one is we call it, we should fill, and this area. So most of the time we should cut. Should cut this area. Take out. And you should fill up this area. This one is okay. It's quite stable. It's very straight line. Okay. So this is, we call it longitudinal or profile leveling. So you must understand about finished road level and existing ground level. And this one is a distance along your road alignment. And of course, we need is a name of authority, title or contract. For example, that's a proposed to build up new highway from Alustar to Taiping. And then the title of drawing, you have skills, you have name of the engineer, draftman name, drawing number, trace number, who checked by. Okay, right. So that is the shape of longitudinal or profile leveling. Okay. So this is the theory. To determine elevation of point space apart. Space apart means that a distance at no distance along a given line in order to obtain the accurate outline of the surface of the ground. Okay, it's also called sectioning. Sectioning, that's we cut the field, we cut the road alignment. Either we call it follow the road alignment sections, or we cut section by sections based on the line of perpendicular to the road alignment. For example, that you are cut like this, get this one. So this one is, we call it, you cut this road, this the alignment. Okay. So you cut this one, section AA. So this one is section AA. And other one, you cut here, you along this road alignment, BB. So this part, you get this profile. You get this profile. Still remember profile I showed to you. This is, we call it the original one. And this one is your proposed route. Okay. So this one is, we call it along profile leveling. This one. So actually we cut along the section BB. The section follow the road alignment. So we call it profile, profile leveling. Okay. Next. The purpose of profile leveling is to provide data from which the vertical section of the ground surface, you know that we call it normally, if the ground is 78.9, 78.9, ground is 78.9, proposed road level is 77.9. In that you should cut. If the value of ground is higher than proposed, you should cut. If the ground value like this, ground value is 20.30, then your proposed is 21.20. This one 20, it's not 26. So in this case, you must fill. So this is ground, and this one is the proposed. This one is ground, this one is proposed. So this one must be filled. If this one, we ground 78.9, and we call the proposed 77.9, we should cut it. Okay? Alright. So this line is called a profile. You already know that. So we continue. And for we call it this slope of this road profile is very useful for project like construction and design of sewerage, pipelines, highway, railways, canals, and to determine cut and fill. Alright. Number two, the essential to run a longitudinal section along various proposed center line and to compare the cost to select suitable one. So longitudinal section along various proposed mean that the section BB, still remember that we cut along the road alignment, the sectionings, and you can see that every, we call it distance, so the reduced levels is not same because it's topography, the original or the natural one. Then we alter, either we cut or fill to make sure our road construction, our canals, our sewerage construction, pipeline, highway, railways, and so on is on your existing profiling. So your existing profiling must be do some correction based on redesign. So we have two works after the effect we carry out our proposal on the existing ground is cut or fill works or process. The profile is plotted as a graph with elevation of various points. Still remember you have, we call it graph paper during your school. And this graph paper actually is the basic to understand about the, we call it longitudinals or profile leveling. And for the vertical scale is keep much larger than horizontal one. So because of normally 5 to 50 times to highlight the difference in elevation. Because we concerned about the verticals, that's why we must enlarge the vertical scale. And this drawing is very unique. What kind of drawing is very unique? The drawing of longitudinal profile leveling is a very unique because X and Y scale is not same. So for the vertical in Y directions, the scale is much more larger than horizontal. Horizontal means the scale for the distance in X directions. Okay, so because we want to understand and keep, and we call it zoom in the vertical process because it involves with the existing ground level and proposed project level. So we know that this process, after we scrutinize, we can have how much we call it soil we should fill up and how much soil we should take out, or we call it we import to another site, or we keep it, or we sell it. So how we plan our transportations, our logistics, our store and so on. Okay, The plotted points are connected by a freehand line. So normally, last time we have a draftman, we plot the point like something like this. So this one, the existing one, we mark the point, and then we are freely draw the lines like this. But nowadays, is all this line is automated by the software. Okay, number 5. So slide number 4, I think you understand. I continue about the drawing. Okay, this is the end. Actually, it's a one drawing, so we continue. Okay, so here you can see that formation level, and this one is existing level. You can see the existing 99. The formation is 100. Okay, this one existing. Okay, and then this is, we call it the proposed we want. We raise up. That's why the value of formation is bigger than existing one. So you can, if you study all this value, so formation level value is raised, and existing level is not raised up. It's something like constant. It means that this one, we call it, we must do a filling job, fill work. Because the formation level is higher compared to the existing level. And this is distance 725, 70. If you project like this, 800, okay, 825, mean that the distance become far and far is a very going to we call it steps. Going to, we call it another value. It's keep increasing. Okay, this is the change. Change means that distance. So don't we call it confused, because this change in meter 7 to 5 meter, and all we call it the existing level, information level, and datum level. Datum is mean that you can adjust. Is it your drawing? We call it, you have enough space. Is enough space for vertical? Yes, you can set this one is bigger. But your paper don't have, we call it a shortage in we call it in y direction. So you change the datum, maybe become only 40.00 meter. Okay, next, cross sectioning. Cross sectioning, what is it? You cut like this. You cut like this. You cut like this. Still remember that? So that is called it cross sectioning. For slope profile, we cut along root alignments. Okay, still remember that? That we call it longitudinal or profile leveling. This is cross sectioning. These operations, you look at, we call it the diagram first. The example of the cross sectioning, where we have the existing one, existing of grounds, and then we are doing filling works here, and here we build up the road or highway. And this one is a finished road level. Okay, so how much we should calculate this one for maybe per 1 kilometer? So we must know the volume. Is it cut or fill? This one, the volume should be filled. So I think for 1 kilometer is the, you need so much soil to fill up, and maybe you become rich after this project complete. This is another, we call it cross sectioning. Still remember that this one is distant 50 meter, 10 meter, 5 meter. Okay, this one is the existing one. Existing this at 98.810. So you get 99.410. You can get this one 99.610, and also this one 99.5, until you finish at 98.00. Then on top of that, you are want to do some embankment on top of that. So the earth formation is 99.900. Okay. So mean that we must have, we call it, fill up this area. This one also same. This is, we call it the field work. Okay, all right. And this is, we call it, what the meaning of the cross sectionings. Number one is operation of leveling of the point at the higher angles on either side of the center line on the proposed routes. I think you know already, you understand. And this is done to find out the vertical section of the surface of the earth on the ground. And the third one is detailed information regarding these methods have in computing the quantity of earthwork. You know why the important about we want to know the information to quantify the earthwork? Because we want to determine or set the price of tender. And most of the roads, very expensive, is normally for earthwork. One part of that is earthwork. Another part is a bridge. And we call it the road pavement, I think is number 4 or number 5 priority. Okay, in the cross-sectioning, the cross-section is drawn in the same manner with longitudinal section, except both horizontal and vertical measurement are plotted in the same scale. So you want to do a measurement of area. For measurement of area, actually we have two. One is graphical method, another one is based on instrumental method. By graphical method, we can get from plotted plan, we can know the entire area. Or graphical method, from field notes, we can know the boundary area, mid-ordinate rules. We will learn this one after this. Under, we call this one, this route. So we are graphical method going to, from plotted plan, going to boundary area. We try to calculate using mid-ordinate rules, average ordinate rules, trapezoid rules, and Simpson rules. Another one we have, don't forget about the instrumental method. Okay, so but we focus on this one for so what we call it, for our first lesson to become a fundamental or basic survey. Okay, area from offset. You look at this diagram first. So this is, we call it slope profilings. And you know the distance from 0, 1 to 0, 2, you have a distance, right? We have a distance 0, 1 until 0, 2. Okay. And then the total length is 0, 1 until this one, HN. So that is L. And this is, we call it the distance from section to section. Okay, and this is the existing one. Maybe this one is 99.0. This one going down, 89.10. This one going up, maybe 99.11. So you can expect, we call it the value, because this one is based on the reduced level. So the more you can see on top here, the reading is high. And you look at this one, because the lowest one, the reading also become low. Okay. So we want to calculate what? We want to calculate the measurement of area. And measurement of area, we have graphical method. For graphical method, we have plotted plan. For plotted plan, we have boundary area. Nowadays, we have the mid-ordinate rules, average ordinate rules, trapezoid rules, and Simpson rule. Okay. So next we have the area from offset for the first method. Okay. So you already know, we call it this drawing. You already know this drawing. Now we're going to this area from offset. Offset are made from a baseline to an irregular boundary. So it shows like this. The straight line, because this one datum, right? Going to one point is from the irregular line. From the irregular line. Okay. The irregular field is thus reduced to a series of trapezoid by right angle offset. You can see that the shape is something like trapezoid. It's something like, you know, you put a straight line, you can see that trapezoid. Straight line. Okay, all right. There are several formulas to calculate area of the figures formed. When the boundary between the offset is more or less a straight line, the trapezoid rules is used. So sometimes this we call it area from offset. You can use, we call it trapezoid rule. And when come to the shape of, we call it is a parabolic. It's not, we call it something like the trapezoid shape. So use the Simpson rules to get a better result. However, the degree of precision can be increased in all the above method by increasing the number of offset. Okay. I think we get this one. Then we go into this one. Mid-ordinate rules. Okay. So here we have an offset drawn at interval. Now we have mid-ordinate rules. So how this, we call it mid-ordinate rules. We have this diagram, so we can calculate the area for this one. So it's not volume, this one we just know the area. So the area from here to here, up to here, and coming back. Because the problem is at this part we have the irregular. We have the irregular like this. That's why we must using this formula, mid-ordinate rules, one of that. Okay, the offset H1, I think I should erase to make sure that you can follow me. Okay, that's good. The offset H1, H2, this one offset H1, H2, H3, you know that, this line. The offset H1, H2, and Hn, the last one Hn. So this one is actually Hn minus 1 because second last. This one is the last one. The offset H1, H2, and Hn are measured at the midpoint of the east division. So the area is equal to average ordinate times by length base. For example, the area H1 plus H2 plus H3 until plus Hn divided by n times by L length. Area number 2, next area, when we have this one, so we go to H1, H2 plus Hn, we change this one, Nd. Okay, Nd and divided by n. And last area, H1 plus H2 plus H3 plus H4 until Hn, the last one, D, where n equal to number of division. Okay, so there is mid-ordinate rules. We call it average ordinate rules. So the second method, average ordinate rules. I think you already understand about this diagram. I think you understand about this diagram. Okay, and this diagram is really important. So how we want to calculate using average ordinate rules for this profile, because this profile is same like the previous one, is in irregular on top. So because of the irregular, you not calculate it very well. Sometimes the words we cut here. You can see on drawing is we call it very simple. People don't care, but on ground maybe it take you a years to fill up. That's why when you design cut and fill line, something like you want to like this, something you want to put like embankment, you must discuss with your clients how much they want to spend the money for the landscape works, or we call it this evening work based on average ordinate rules. Okay, the offset, I follow this one. The offset O1, O2, ON are measured at the end of each division and are spaced apart at equal distance D. This one D. The same, huh? This one you times 1, 1, 2, 3, 4, 5, 6. So they should, we call it have a 6, 0, 1 until HN. Area is equal to average ordinate times by length of base. Length of base. This one, length of base. Author from here to here, distance. Okay. So the area equal to 0, 1 plus 0, 2 plus 0 n. Okay. Divided by n plus 1 times by L. And for area, O1 plus O2 plus no student plus ON, and then the area we can simplify with the ND, summation of O divided by N minus E, where N is a number of the division. Alhamdulillah. Alright. So we call it the third method, trapezoid rules. Trapezoid rules. So same drawings, we just change this one. Area of first trapezoid is 0, 1 plus 0, 2 divided by 2 times by D. And average and area for second trapezoid is 0, 2 plus 0, 3 divided by 2 times by D. And area of last trapezoid is ON minus 1. This is from the previous owner, right? Area of last trapezoid is ON minus 1 plus ON divided by 2 times by D. And then we sum up again from this one, we change to this value, mathematical form. Summing up at A equal to D, our distance D. Okay, 0, 1, this one 0, 1, 0, 2, 0, 2, divided by 2, plus 0, 2 plus 0, 3, 0, 2 plus 0, 3, okay, divided by 2 until we got the finish like this one. So plus Qn plus 0 n minus 1. Okay, and we are going another step. Is easy. So summing up, so the area for the trapezoid rule is equal to D in bracket 0, 1 plus 0, 0 n, the last one, 0 n, the second last, divided by 2 plus O2, this one O2, and this one plus O3, this one is O3, alright, plus, we call it ON minus 1, N minus 1, N minus 1 like this. Okay, so this is the formula you must understand, and then it's very easy for us because we don't ask you about the formula we want you to apply in your works. Okay, Simpson 1 third rule. Okay, Simpson 1 third rule. So this one is number 4 method, how you want to calculate. First, you must understand this. Simpson 1 third rules. We already have, we call it the trapezoid rule, Simpson rule. We have average rules, and then mid ordinate rule and so on. We already calculate, right? Okay. So we should go to this slide. How we call it mathematical models to help to find out the area using Simpson one third rule. Okay, maybe they have some special requirement. Okay, number one, you look up at this one. Area of trapezoid ABCD is 0, 1 plus 0, 2 divided by 2. So they look at this point. 0, 1 and then plus with 0, 3. Okay. Divided by 2. These two value divided by 2. Divided by 2. Okay. And times 2D. Okay. So actually this is, we call it area of trapezoid ABCD until they modify the formula. They look at, they consider this one, you can get this value, total area. For we call it total area for the Simpson one-third rule is equal to area D divided by 3. So for example that your D is 20 meter or we call it 30 meter. So you divide it by 3 is equal to 10. Is equal to 10. Alright. And then you are going to the O1. O1 like this one. And then ON. ON like this one. Okay. And then plus, this one plus, constant, this one D3, constant. O2, you look at this one, O2. And then you're going to O4. O4, like this line. Okay. Until you finish at, we call it ON minus 1. ON minus 1, like this. Okay. And then you plus with 2. O3, O1, O2, O3, plus O5, 3, 4, 5, O5, plus until you finish ON minus 2, ON minus 2 like this. Alright. So this one is the simple one-third rules, how you want to use it to calculate the area and the total area for the total area. This is the reminder, something that you must remember. This is a warning. The essential condition for the application of Simpson rules or the Simpson rule formula is the division of the required area into even number of segments. Example, the number of offset should be odd. Alright. Okay, next, source of error. So what actually in this calculation, in this we call using the modern survey equipment, we still have error. So you can see that what the source of errors like to tell you. Number one, or selection of offset and interval which do not fit properly with an irregular boundary. For example, that you have something like this. So you're profiling, what we do, you go the lowest one, the peak one, and then the higher one. You no need for you to do the offset like 1 meter, 1 meter, 1 meter. It's a very detailed. Sometimes it give you a very tedious works. Maybe take years, but the drawing, or we call it this survey map, we need immediately for determination. Either the company want to invest that here or not. Alright. Number two, using too large condition square, which is difficult to estimate partially square. Using too large condition square, making it difficult to estimate partially square. The third one is adjustment of latitude and departures are not made in accordance with true condition. So we need adjustment. And we adjust, but sometimes it's a long leg to make sure this one, the line is very good and fixed. But actually, after we do some measurement and adjustments, or we call it something, the value that we are manipulating with extra formula, and it's not made according with the true condition, mean that what we take is not already the original one of objective of engineering survey. Post selection of the origin resulting in minus value of coordinate and double meridian distance. I think you remember this one. You can see the drawing again. Or setting of the equipment and failure equipment constants. And number C, inaccurate determination of the equipment constant. That's maybe using leveling or tenolite. So that leveling in tenolite you not calibrate for enough for we call it 10 years. It means that your data is not good. And some of we call it university they will reject the student works based on the schedule they give it, right? Okay, this is we call it examples 3.3. So if you we call it your plot, this one is something like your earth profiling, and then you know that the distance offset length 23 for put here 40, 42, this one 30, this one 32, this one maybe 40. Okay, all right, 100. This is 100. This one is 32. This one is how much? This one. So we should erase first. Oh, sorry. So 120 is only 10. Only 10. So this one is maybe 10. Now we're going to like this. Then we're going to 22. Okay, so when we do some connection, something like this profile have we call it enough data. So the question is determine the area in hectares between the line A to B, from A going to B. Okay, and a stream of offset taken at regular interval 20 minutes along the line AB. Use both trapezoid and Simpson rules. Okay, we go next. So these are the solutions where we call it to determine the area of vector between line AB and a stream for offset taken at regular interval of 20 meter along the line AB using both trapezical and Simpson rules. Okay, that is the question. So how they solve it? So an interval d equal to 20 meter. So d is the trapezoid rules. A equal to d and we call it O1 plus my the last one OM divided by 2 plus O2 plus O3 plus O4, and then this one the second last. This one second last. So when we have this one, we from this formula we just put the value here. 23, 22, 40, 42. This one 30, this one 32, this one 60, this one 10, another one is 14. So the area is when calculate this one is 5,001 meter square. So the area is equivalent to 0.5010. So you can Google. We call it unit conversion. Unit conversion because you have meter, you want to change it to hectares. All right. So okay, we are continue. First, you remember that we're using a trapezoid rule. Remember. Now we're using Simpson rule, but based on the same project of this. Okay. So you can see that this is our acre, 0.50 acre, all right? But using, we call it Simpson rules, you can get area is 0.5260 acres. This one is 0.5010, mean that this one is high accurate data, we call it. Okay, so in some rules we're using a different formula where we call it, this one is our distance divided by 3. Still remember D? You still remember D? Our distance, this one. I will show you. Now this one is our D. Yes, this one is our D, our D here. Okay, alright. Next, what we have, two formula we work out with from one problem, and you can see that the Simpson rules you can get after they pass through this formula, where they have by their own we call it mathematics. Okay, so you can see that is Simpson rule give a value is 0.5260. This is Simpson rules. So another one is using what we call it using the trapezoid rule. So you get A area is 0.5000. 0.50. So 0.5. Okay, this one in hectares. So this one is the trapezoid rule. So you can see that this one is higher. Using we call it Simpson rules, is higher numbers of safety. But if we call it this one, so the sign become reduced. Okay. So we call it sorry. So the trapezium, the value here is less. Even the same formula, this one is higher, this one is less. All right. So you can see this result. You compare it with this one is a result B, and this one with a result A. Same two different methods, but to answer one industry or one solution. Okay, in works you can use both way. If you're most like we call it trapezoid, go ahead. If you're more like a Simpson rules, is go ahead. Okay, so this one is a bonus. You try. Bonus question. Calculate the area of the offset by using average ordinate rules and ordinate rules too. Compare all the two answers and determine which method is more accurate and precise and why. So you justify. This one another, we call it another mathematic model how to get, we call it the area. So using the average ordinate rule, we can Google and mix ordinate rules, or if you have a textbook also you can look at these two, average ordinate rules and mixed ordinate rules. Okay, then if you get the answer, should be answer 1 and answer 2. So you compare. And what is your feeling? You write here. Okay, determine which is method is more accurate and precise and why. Okay, now we go that measurement of volume. So in volume, we have measurement of volume. We have cross sections, we have level sections, we have n area formula, we have prism formula, then we have 2 level section, side hill 2 level, 3 level section, multiple level section. You also can use spot level method for measurement of volume, square method, triangle method, and the last one we have contour line method to propose and give feedbacks to we call it the industry or academic. So this one is a contour line method, and then we go for this one. The most common method used is a cross-sectional method, spot level method, and contour method. And it's a rare to measure volume directly. Indirect measurement are obtained by measuring distance and area, bring a relation to the volume desired. The most common method used are cross-section, spot level, and contour line methods. Okay, this one is method of measurement. Now we're going for volume cross-section method. So what do we mean cross-section method? Something like this. Okay, so you have, we call it your original ground. So you have the original ground. Okay, this is, we call it maybe your uh, your 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 project in the future. So this one is slope like this. So this one is slope like this. So we cut this slope because we want to make sure we can have a car over here, right? The car going up and then the car going come in. And this one also we want to cut the slope to make a smooth transition of highway. So we have a first rider going to left and a second driver going to right. Okay, this is something like no, it's a level section. It means that this is your road, okay, and your purpose. This one the original. This one is your purpose road, and this one is your original. This is a type of cross sections. And if I will call it erase like this, you can see the terminology. So this terminology you must understand very well, because sometimes it give you, we call it it give you the calculation of volume. Okay, so if you look at, we call it this level sections. Okay, level section means that we consider this one is straight line. This one is a straight line. Meanwhile, for the two level section, the lines is become, we call it slope. All right, have a slope and not very steep. So from this point, center point to the base of the purpose road, we call it H1. And road for the both side, we call it the breast of road D. And the D is from the center line of roads to the edge of road construction. And then is D1 also is from B, and then it involved with D1. Okay, at the end of D1. So this one, D1, D2 is similar, B is breadth, and then is H. H, we call it normally the inner one. We are measuring from this center to this center. Okay, so you can get H, or we call it H of the embankment, height of embankment. S equal to 1, S equal to 1 means that the slope 1 to 1. Horizontal like this, horizontal, this one is vertical, horizontal 1, vertical also 1. And the angle, if you measure, is 45 degree. 45 degree. Okay. Now next you can see this one H1, H2 is not different because this one two level section. So this point is H1, this one is H2, and you have N. N equal to 1, mean that the slope gradient maybe is 1 to 1. And this one is your slope S over 1. So S over 1 mean that if your S is equal to 1, so your S value also 1. So the scale is 1 to 1. Okay, and now this is, we call it the breadth of highway, the breadth of the highway or roads, and this one is D, from the center to the cutting edge of the road. Okay. So this is we call it the type of cross section. So now we are coming back to cross section method. And this is the introductions. Already we call it, give you some introduction. This one and this one and this one. So this one we have 3-level section. We have 5-level section. You can see that all they call it the H, the B, H2, H1. The value is going up and going down. This is, we call it the original topography. We cannot avoid that. But this one we must cut, and it is our new proposed level for road or highway. And of course we call it in this method. So we have a cross section method. This one you also can have, we call it this one the existing slope, but we want to build up the highway like this. So the car going further up and the car coming. Zoops. Okay, so this method is slight hill to level, where occurred in passing from cut to field and on site hill location. Alright, so I go for this one first, cross-section method. Most commonly used in computing volumes. So we want to calculate about, we call it how much earthwork we should fill out, how much we call it our one should export out from the site. So this cross section, and we call it the longitudinal cross section, slope profiling. Is we call it ground profiling to show, we call it the ridge level. It's really important because we want to calculate the volume, and this volume we calculate the tender value. And from this one also we can have your calculate your manpower, or we call it site organization, or we call it company organization. Alright, so the total volume is divided into a series of solid by the plane of cross sections. So you can see that multi-level. We are calculating 2 side of roads in different way because the H1 and H2 is different. Okay, for example, the spacing of the cross section depend upon the characteristic of the ground and the accuracy desired. So if you want like this is you have a cross section. So this is your cross section. You can get this value. And another one, you have this one. Just 3 readings, so you get this one. Same side. So this one is more accurate if compare it to this one, because we don't have this data. We don't have this data. Okay, so we want this, we don't want this. So this one is accurate. This one is less accurate. Okay, when the ground is irregular, the cross section must be taken close together. When the ground is irregular, the cross section must be taken close together. And if you can see that this one is regular, okay, the cross section, when you put like this, you cross this one, cross section like this, section AA. Oh, sorry. So we have section AA here. Alright, so you must cut it very, very near to make it, you have a clear picture about this one. And the volume is calculated by average and area formula, or by the Price-Model formula. So you can use 2, average and area, and Price-Model formula. Okay, we have these 2 methods. So we finish this one, we finish this one, we finish this one, and we call it slide 32, where you can see this one is the first one, level section. So this level section, because we have the shape like this, the original one, this is, we call it our desire. We have a slope, maybe is 1 to 1, or maybe 1 to 2, or maybe 1 to 3, or maybe 1 to 4. And remember, is 1 to 1 is something like this. Is 1 horizontal, 1 vertical. Is 1/2 like this. 1 vertical, 2 horizontal. Is 1/4 like this. 1 vertical, 4 horizontal. Okay, that is how we determine this one. And you have, we call it H, we call it the height of the embankment after we cut inner. And for the outer one, H1, the value sometimes same or different. And this The B is you set either your road you want 8 meter, you want 5 meter and so on for the both side. So that is the B. And D is from the center line going to the edge of the slope is D for the left. For D1 for the right one. From the center here going to these edges. Okay. And of course we have this formula D equal to D1 equal to B divided by 2 times SH. And we're using this formula only. You must remember this one. Is area equal to B plus SH times H. What is B? This one is B. Your width of your road. What is SH? Okay. So this one you have we call it as for example, wait a minute, where is my wait oh, this one. Okay. And B, you already know this one is B, you know it S, something that this one S. So I will draw again. So your S like this one S. Okay. Now our S is equal to the maybe is 1. Okay. And then H, this one. And time in bracket and time again H. So H is the height of the slope from the original ground to the proposed line you want to build up the highway. Okay, so that is the formula you should remember this one. Area is equal to in bracket B plus SH close the bracket time by H. You must remember this one. And how about an area formula? And then we look at the Priest model formula. And then we go for the source of error. Okay, next. An area formula. Okay, an area formula we also know as the trapezoid rules. And if you have a trapezoid rule, you have a friend of them, if we call it prism rules. This one. So these two formula also want to calculate about the volumes. How much we call it our calculation? Is it maybe 200 billion thousands of soil we should using for fill up the project from Pulau Pinang to Ipoh new highway? Or maybe you want to cut, we call it the soil. Maybe it's 2 million meter cubes that we should take up from your side because it's involved with the cutting of the earth profile. For example, that you cutting a lot in Cameron Helen section from Simpang Pulai to Simpang Pulai, maybe to Ringlet. Okay, right. So we look at number one is an area formula, or we call it trapezoid rules. How do you calculate the volume? The volume is assumed to be equal to the average of the area of a 2n multiple by the distance between them. So, volume between first two sections is V1 equal to A1 plus A2 divided by 2 times L. So, volume between next two sections, so volume 2 A2 plus A3 divided by 2 times by L and so on. And the total volume equal to V1 plus V2, V1 plus V2 plus V3 plus V4 until last one, Vn. Or we can say that this is the formula you must remember because they already simplified. So the volume for the trapezoid rule is equal to bracket A1 plus An divided by 2 plus A2 plus A3 area 1, area 2, area 3 plus area 4, 5 until the last area. where area 1, area 2, area 3 are at the end consecutive area and L is the distance between them. Meanwhile, if using, we call it Priest model formula. What they consider? They also, we call it a Simpson rules. Simpson rule and Prism formula is the same. And the meaning of the various symbol used in this formula and its separation. So total volume based on Simpson rule or the Priest-Moidal formula is equal to volume, your length L, your distance divided by 3. So in bracket, area 1 plus 4 area 2 plus A3 plus A3 plus 4 4A4 plus 5 until you plus A n over 2. N over 2 means that's the area for the second last, plus again for the area second last, plus 4 area second last, and lastly plus 4n, the last area in your slope profile. Or we can do like this. Volume equal to L over 3, area 1 plus 4 area 2 plus 2 over 2 area 3 plus 4 area 4 plus 2 area 5. You plus until you get 2 area the second last plus the 4 area, we call it the second last, this one the 2 second last, this one the second last, and plus with the last area in your slope profile. And then they are doing this formula. You must remember this one. Okay, for volume for the permeable soil, so L over 3 maintain in bracket A1 plus AN, the last one plus 4 A2 plus A4 AN. This one we call it even number, and plus this one is odd number, odd section. Okay, plus 2 A3 A5. A3 A5 is odd. 2 4 6 is even. Okay, this is how you should understand and which one mathematic model you should take out and remember. Okay, so these two methods also has, we call it error. Number one, estimating the ends area, because at the end area we just estimating, we just something like estimate. That's why sometimes the actual one we are calculations, because the calculation we are assume the model on site is different. That's why if you can see that in tender maybe 2 million meter cube we should fill up, and on ground you already fill up 2.5 meter cube 2.5 million meter cube of soil you fill up. You must discuss with your engineer and we call it the clients to claim for the VO, variation order, because you do a lot of work. Failing to apply Priest model and curvature corrections. Okay, sometimes the area is very big. We call it root alignment is very far. And then your data, is maybe the line for interval, maybe the put is another 20 meter. So you cannot have good curvature. So that's why sometimes we must understand that our Priest model formula is not considered the curvature correction. Okay. Sometimes like this, you take the value like this. Then you put here and here. It is your slope profile. So when going to ground, maybe like this. It's going to down and then it's curved here. So when it's curved, our calculation is already wrong because we just assume the straight line. Okay. Computing the area of cross section beyond the limit justified by the field data. Well, sometimes we have calculation, we say that it's very good, yes, for tender, but come to the site doing the work in progressing, so you must check the data, we call it calculated data. Normally we have the difference. either going to, we call it going to downs, we call it our calculation and reality, and then the reality is going down, or is going raise up. Normally it's going to raise up. Okay, computing the volume beyond the nearest cubic meter. If you have a software that can calculate this profile to the nearest cubic meter, so it means that your result of calculations in terms of the volume of area or cut of field is accurate. Okay. So now we go for the example. Example 3.4. How they calculate about the volume for the embankment. So because they want to do a road constructions, so they have, we call it a data from leveling survey. So from this one you convert to this slope profiling. The resistance 0, 20, 40, 60, 80, 100, 120. This one 42, this one 64, this one 72, this one 15, 18, 26, and this one is 11. So when you plot this one, it's something like this slope profile. Okay, this slope profile like this. Okay, now we continue. Okay, when using a Price-Medal formula, you calculate by this one, L over 3 A1 plus AN. I show you where is AN. A1, and then this one AN. This one A1. Okay. Alright, when you calculate, you get the volume is 4380 meter cube. This one is using a Simpson rules. For the trapezium rules, we calculate A1 plus AN divided by 2. So, and then plus A2 plus A3. So, this one AN, last one A1, this one is A2, this one is A3, 4, 5, 6. Okay, this one also 1, 2, 3, 4, 5, 6, 6, or AN minus 1. This one we call it AN. Here, sometimes we call it AN minus 2, the second last. This one and the second to last. Okay, right? So when we calculate this one, and you must remember time L. Time L. So your length. So remember your length here. This length. Alright. So you get 4,450 meter cube. If you compare to this one, which one is higher? So trapezoid gives you higher and Simpson gives you a lower. So you must remember sometimes you calculate the volume of soil. So you must remember calculation. Calculation, which formula you use? Either you use a Simpson rules or you give a trapezium rules. Alright? So if using a Simpson rules, your volume is lower down. If using trapezoid rules, your volume become increases. Okay? We call it another. How we want to calculate the volume based on contour. So we call it spot level method. Alright. So spot level method like this. Still remember you have a grid. I already asked you about to set up the grid on ground. Still remember that? And then we go to get the data here from point, this point, or we get all the data from here. This one we call it spot height. And also we have another like this method, and also we call it this method, right? Okay, so I show you this one is very simple one. So maybe they have, we call it TBM, this, we have our instrument. So they observe this point. Here they put it, we call it traversing. Okay, so this one is TBM. This one is maybe a point A, B, C. This one is a 1, 2, 3. If you measure this one, we say that A2. If you measure this one, we call it C3, point C3. Okay, so there is a, we call example. Before that, we go, what is the introduction? Spot level method. Number one, this method is usually used to calculate large amount of volume and deep area. Large amount of area and deep area. Place like basement, underground tanks, buildings, or maybe we call it army camp and so on. And formation level and ground level must be determined first on the grid points for a particular area that needs to be executed. You still remember that in front of UITM Pusat Islam, you set up, we call it your grid system. So this is for the, we determine first and then we go some inspection, all right? So and then we choose. Normally for the site, for the client, they already give you that land, they want to build up, so you no choice, you must calculate the spot level on this, on the site, on that particular site. Okay, this method also known as a unit area method. Spot height level also they know as a unit area method. And there are two ways that can be used in method. The methods are as follows. They also have another two. One is square method, another one is triangle method. How to calculate the volume based on spot height. Okay, we have example here. Let me erase this one. Maybe after this you want to see the data and so on. I think you understand. This one I think you already carry out your leveling survey is the same principle. Okay, so for example 3.1, the question is a detention basin. No detention basin, something that's you are going forward to UiTM Pulau Pinang through the main gate, and you can see that a football fields on your right, sorry, on your left. So you say this one is the football field? No, actually this one is, that one is for UiTM Pulau Pinang a detention basin to control our floods, especially flash flood, because Permata Ampah area is a flat area. And then UiTM, we raise up the levels a little bit to make sure that we can sustain even though we have a very flash, we call it flash flood, okay? And if you go to the Crystal, behind the Crystal Hostel, you can see that beside, we call it Success Office for UiTM, you also can see that a football field, but this one is not a football field. There is our second detention basin to control the flash flood. Okay, all right, there is detention basin. It's planned to be executed at a new residential area. A surveyor was appointed to conduct the leveling survey. The data of the risk level were recorded as shown in figure 3.5. This one is data. They have 9 data over there, and then they also measure about horizontal and vertical grid. The data of the risk level were recorded as figure 3.5. Calculate the volume of soil needs to be excavated on that area if the formation level is proposed is 10 meter. So, and from average mean sea level, use spot level method, square method to calculate this example. Okay. So we call it square method, and then we have triangle method. This is the same layout. So we call it the square method. So the square method, we record back reduced level based on grid A, B, C, D, E, F, G, H, I, and we know that we should cut at 10. So we minus 13.15 minus 10, we get 3.15. At point D, 13.95 minus 10, we get 3.94. And then for H, 16.10, you minus by 10, so you get 6.10. You should cut. It's around 20 foot. It's a very deep, it's a very deep. And then we have the existing one, 14.67. We cut at 10, so the depth of cutting is 4.7. So you look at this one, the number is 1, B is 2, C is 1. How you know this one? Because you know this one. If this one we consider 1, this one is considered 2. This one is considered 1. Based on your locations. Alright. Okay. And if E we consider 4, why? Because E is in the middle. A, B, C, D is in the middle. So this point we consider 4 numbers. Why 4 numbers? This value share with this side. This value share with this side. This value share with this side. This value share with that side. This one B, this value and this value. This one called 2. This one is 1, 1. This one is considered 2. This one 1 and 1. This one 2. Alright? So we have numbers of height actually, because you're sharing the grid box. And 3.15 you time by 1, so you get 3.15. 3.70 you time by 2, because at point B 2 sharing, so you get 7.40. And for point E is 4.80, you time by 4, because you're sharing with 4 neighbors, you get the value is 19.20. And when you total up and divided by X is equal to 73.94 meter. This one, Alright. So N is 16. 1, 6. Okay. And another one, we call it a triangle method. This triangle method is A is same. This one all same. Like first example. So depth of cutting also same. The difference is like this here. Because if we consider 1 is 1 for triangle method. If we consider B.2 for the square method is 2, here we consider 3, we call it. And then C, we consider 2. D, we consider 3. E, last time we consider 4, now we consider 6. Okay, this is we call it triangle. Triangle that you have like this. Because you have this line. That's why you have this line. Last time we call it 4. Now it's going to 6 because this point is 6. Okay. Okay, then after you finish, you get 24 and number with 111.755 meter. This one is 73.94 meter. Okay, 2 methods give you to answer and continue. We go for, we call it square method and triangulation. So from this table 3.5 and table 3.5a. So from this one, okay, area of depth of excavation you can get 37.94 times 60. This one. Oops, sorry. This one, 73.94 times by 60. This one. So you get 4.62 meter square. So excavation volume, base area, times by average depth of excavation. So excavation volume is 30 times by 35 times by 4.62. So you get 3,465.95 meter cube, okay, of soil. You should excavate and export it out to make call the construction, we call it basin, to control the flash floods for the residential area. And if using a triangulation, same, that you have 175 divided by 24, you get 4.66 meter square. And then from this one, you put this value here, and base the same, 30 by 25, the area, you time by 4.66, so you get 3492 3492.20 meter cube. So you can see that which one is higher. This one, triangle. This one, the square is value. We call it, the calculation is less. So we have square method and triangle method give you a different answer based on the mathematical model or the assumption that they made, even though you calculate the same side. Okay, we go for it, we call it contouring line method. We have another 5 slide and then we finish. That's good. Contouring line method. Okay, contour line passing through point of equal level, for example like this. You have this one is 100 meters. All this point is 100 meters. And then you have 200. All this one is 200. And this one is 300. All this one is 300. And then this one is a value for 400. So all the line like this is the same value. We cannot connect the line with different value because it's not give you the accurate contour line. Okay, contour interval, vertical distance between two consecutive contour. If you cut this one, you put like this line, so you have, we call it distance, right? Okay, this one is 100, this one 200, maybe 300, maybe it's 400 like this. So you have this point, you have this point. Okay, you have this point, so you can get this something like shape like this through this contour. This one is vertical one, and then this one is your distance D. Your distance D. Contour interval, vertical distance between two consecutive contour. This one is D. And interval depend on one, the nature of the ground, scale of tile, and two, purpose of the survey. So interval depend on what? So interval mean, if you want to build out, we call it housing. So maybe your grid system you set out is 4 to 20 meter or 50 meter. If you go, we call it a survey for the state. Maybe you can take around 100, around 50 meter and 50 meter. It's based on nature and the purpose of survey. Okay, contour characteristic. The contour line are closer near the top of the hill or high ground and wide apart near the foots. This indicates a very steep slope toward the peaks and flatter slope toward the foot. You can see that this one, when you cut this section, you can see this one is line number 1, line number 2. Here you have something like this. Because this part is very steep. And then is this one is quite okay. So this one is very steep. This one also is this one is quite flat here. Is something like quite flat. And this one is very steep. And this one is quite flat, very steep, and then flat backs, and steep and then flat. Okay, So if you know, we call it, it's not this one is something like this, because this one is a different, you know. Okay, so we have something like this. You climb up, and then flat is then going down. Okay, and here you must take the curvature. Okay, the contour lines are closely near to the bank or valley, pond, etc., and wide apart toward the center. This indicates a steep slope near the bank and flatter slope at the center. So this one is the natural one, the original that God created. And the third one is a uniformly spaced contour line indicate a uniform slope. It's quite uniform. The distance is not really much. We call it have a gap. And then a contour line always form a closed circuit. A closed circuit means that they will loops. And you can see the dotted line. This one is hang. This one is hanging. It's something like this. So this hang show in dotted line over here. Dotted line like this. Okay, it's hang. Alright, hanging. Contour line always form a closed circuit, but this line must be within or outside the limit of the maps. Contour line cannot cross one another. We cannot say that this contour line and this contour line can cross. Cannot. Unless this one is a dotted line. It's a dotted line like this. Maybe they have, we call it something under the first one. But this line may be within or outside the limit. Contour line cannot cross one another except in the case of overhanging or cliff like this or like this. But overlapping portion must be shown by a dotted line. Contour line meeting at the point indicate a vertical cliff. Okay. Oh, sorry. Oops. So the example. So you have, we call it how many points you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. You have 16 points. Okay. And then a contour line as shown in figure was produced by a group of students from Faculty of Civil Engineering UiTM Perlis using observation data from tachometry survey. Show that calculation for determining contour line of 48 meter in line P. This one is line P, 48 meter. And if the line of line P is 10 meter, next find the contour line for the 48, 49, and 50 meter. Okay. So here mean that you have one portions. Here they know that the value is 48 meter. They want you to find out the friend of 48 meter because they want to plot the contour. And they also want you to know about trace, we call it 49 and 50 meter. Okay. So the solution is like this. Okay, right. I show you this one. I show you this point. I can consider this one point A. This one, this one point B. So when I saw the diagram, this one A and this one B. So you look at this value, which one is higher? So I know that this one is lower, this one is higher. Okay, so from this one we know that 48.4 is value. We are minus 47.4. 4 you are subtract with 4 is equal to 0. This one dot. 8 minus 7 equal to 1. This one also dot. Mean that the point B is higher than point A in 1 meter. This one, 1 meter. So we draw like this. Okay, we draw like this. And you know that this one is 47.4. We know that this one is 48.4. So difference is 1 meter higher. Now, based on 47 and 48, you must find out the contour 48. I estimate like this because this one 47, 48, these positions. So we want to know the position here. What is the value for the 0.48? What is the distance? Because we want to measure using a ruler. Here, what is the value and what is the value here? 48. Okay, so you don't know about, we call it this value, we consider is x. And again, we go for the questions. What is the grid? Determine the contour line P. If the length of line P is 10 meter, let's find out the contour. Line P is 10 meter. Mean that is every grid we have 10 times 10 meter. So coming back to this one, I know that the overall this one from A to B is 10 meter. We don't know about X. So how we calculate this one? Okay, so let me erase this part first. I think you understand this. And I think you understand this. And you understand this. Then you understand this. Okay, so how we want to identify about X? So based on this formula, we know that X and Y equations. For example, that if I get 10 meter in horizontal, so you can get 1 meter in vertical. 10, so you get 1 meter. Alright, then we go for the second equation using X. X we don't know. X horizontal is equal to what? We don't know. So what we want to know is from this one, you can calculate this value actually. How we calculate? We take 48.00. You minus with this one, the value at point A, 47.40. So we got it 0, and this one is 0. So you get 6. 0.60. This 0.60. 0.60. So you put here 0.60. Okay, 0.60 meter. Then you cross this section like this, mathematics. So 10 times 0.6 is equal to 1 times X. So if you are using 10 divided by 1, so you want to search X value, so mean that X equal to 10 times 0.6 divided by 1. Divided by 1. So you will get the answer, and the answer is this distance. The answer is that distance. So 10 times by 0.6 is equal to 6. Okay. All right. And 6 divided by 1. Okay. So you get the answer is 6. Mean that 6 meter. So you measure from A using, we call it a tape, or using, we call your ruler, is 6 meter here. So you find out this point 48 meter. And then after they will call it, go for these formulations based on this one, these boxes, this one, 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 and this one. So they can get 48, 49, 50, 49, 48 contour line. They're using this formula. or this example. Alright, you can also use this example. So by that, thank you so very much. We finish our chapter area and volume. Thank you so very much.
Okay, doktor.
Thank you, Doktor.